answers which are the doubts from all of you, right? Then the first question. See, A is a set given in set builder form, B is another set given in set builder form, and they ask us to find A union B. And for this A union B, the options are A or B or empty set or the natural numbers, like that. Okay. For this question, the options are A, B, natural numbers and empty set. You need to choose one among these four, right? And for that, first of all, you need to list the elements of A. So how can I list the elements of A? So to list, since n is a natural number, you need to replace different natural values in the place of n. So first natural number is 1. So if you take 1 in the place of n, so just try to calculate its value. 4 power 1 is 4, and this is minus 3 minus 1. 4 minus 4 is 0. So it is 0. Then if you take second natural number 2 in the place of n, think about it. 4 square is 16 and 3 2s is 6 and that 1 is 7. 16 minus 7 is 9. Then the third natural number 3. So if you take n is equals to 3, 4 cube is 64, and then this is 3 into 3 is 9. Okay, and then minus 1. So minus 10. 64 minus 10 is simply 54. And these are the elements of set A. And now just you try to find the elements of set B. Here directly the rule is n times of n minus 1. So if n is equals to 1, 1 minus 1 is 0, 0 is a number of B. If n is equals to 2, take it here it as 2, and 2 minus 1 is 1, 1 into 9 is 9. And then if n is equals to 3, 3 minus 1 is 2, 2 nines is 18. And if n is equals to 4, 4 minus 1 is 3, 3 nines is 27. So like that, if you observe, all these are just simply the multiples of 9. Is it right? 0, 9, 18, 27, all are the multiples of 9. And whereas if you observe the elements of A, all these are also multiples of 9, but these are only few elements of set B. In set B we have all the multiples of 9, whereas in set A we have only few multiples of 9. So from these two, it is very clear that A is clearly a subset of B. Since A is clearly a subset of B, A is the smaller set and B is the superset. So for these two sets, if you apply intersection, then the intersection part is the smaller set A, whereas if you apply the union, then that union is the larger set, superset B. So here they are asking us to find A union B, and your answer is B, and this is B at the end. So if A is that set and B is this set, then if you find that A union B and that A union B is B, okay, there ends the first problem. It's actually a simple one, okay. Then look at the second one. I will erase this for the space concern, okay. Then we need to analyze the second problem. Just look here, what is the question? A contains the ordered pairs xy such that y is equals to 1 by x. B contains the ordered pairs xy such that y is equals to minus x. See, here y is equals to 1 by x and here y is equals to minus x. In both these sets, there is a rule given for y, okay, and we are thinking about A intersection B. A intersection B means what? A intersection B means the elements which are common for both A and B. Since we are searching for a common element in both A and B, for suppose if you take an element x comma y in A intersection B, what will happen? If you take an element x comma y in A intersection B, then for sure that element x comma y is there in A as well as that element x comma y is there in B. Usually in a set we will consider the normal numbers like x, y, a, b, 1, 2, 3 like that. But here these two sets are somewhat special. It's different, okay. Here these two sets contains these points x comma y, and that's why we are taking the element as x comma y. See, x comma y is an element of the first set A, then from there it is clear that y is equals to 1 by x. Whereas since x comma y is an element of B and y is equals to minus x. So if you observe, from here y is equals to x and from there y is equals to minus x. So if both are y, right, that's why 1 by x is equals to minus x. And since 1 by x is equals to minus x, if you simplify x into x and then minus this side, you will get that x square is equals to minus 1. Just try to analyze it. Since 1 by x is equals to minus x, you will get that x square is equals to minus 1. So x square is minus 1, as they mentioned that x is a real number. Square of a real number is negative, it is not possible. Square of a real number is always positive or 0, but here it is minus 1, so it is not possible, and that's why, see, this is not possible, and that's why y is equals to 1 by x and y is equal to 1 is x is not possible. So we don't have a common element in these two sets, so this A intersection B is an empty set. There are no common elements for the given two sets. Okay, just have a look. Here set A is given with this definition, set B is given with this definition, and we need to find out A intersection B. That in the sense, the elements, the points which are satisfying both those definitions we need to find. So if you search for that, you have a contradiction, and it clears that there are no common elements for A intersection B, and hence A intersection B is an empty set. Okay, this is another simple problem, and then I have two more problems now on the board. Just have a look at, I will erase it, and then I will discuss the third one. Okay. Then if it is come clear, then you just think about the third one. You just read the question and then think about it. Yeah, if you look at the problem, the third problem, there is a set S and it contains the first 100 natural numbers. S is equals to set containing 1 to 100, and we need to find the number of subsets A of S. Just try to analyze this word. A is a subset of S. Okay, A is a subset of S such that the product of the elements in A is even. Just analyze that word. The product of the elements in A is even. For suppose if I have some numbers, whenever the product of all these numbers is even, if at least one even is there among the collected numbers, for sure the product is even. And whenever it is not even, it is not even if there is no at least one even number. If all the numbers are odd, then only the product is odd. If there is at least one even number, for sure it becomes even, right? Okay, if you have one even number, then for sure the product becomes a multiple of 2, then it becomes what? Even, right? And that's why the problem is asking you to find the subsets of S for which the product of the elements is an even. So my idea is total number of subsets. How many total number of subsets are there? Here for the given set S, the total number of elements are 100. Then from there it is very clear that total subsets is equals to 2 power 100. Number of elements in S and then total subsets. Right. And we are searching for number of subsets A. That in the sense such that the product of the elements is even. So what I do is, you just separate even numbers and odd numbers. Okay. Totally from this 1, 2, 3 to 100, there are evens and odd. You just separate evens as well as odds. And if you collect the odd numbers, totally there are 50 odd numbers, right? And these 50 odd numbers separately will make 2 power 50 subsets. Is it right? Absolutely. Okay. Just think about it. Totally there are 100 numbers, and now there is a chance to make 2 power 50 subsets using those 50 odd numbers. And the same way we have 2 power 50 subsets with these even numbers also. Okay. See, there are subsets which whose elements are not completely even as well as not completely odd also. Is it clear? Just think about it. The number of subsets which are formed only odd are 2 power 50, and the number of subsets which are even, only formed with even, are again 2 power 50, but I don't need the 2 power 50 now. Okay, right? See, since the total number of subsets are 2 power 100 and the number of subsets which are only forming with the odd numbers is 2 power 50, so if you choose any one subset among these 2 power 50, that subset must contain all odd numbers. If you multiply the elements of that subset, it is clearly odd. But we are searching for the set whose product of the elements is even, and that's why this is a complementary part for our requirement. And that's why, so our required answer at the end is simply nothing but total subsets 2 power 100 minus this 2 power 50. So from this 2, there is a chance to write this 2 power 100 as 2 power 50 whole square minus 2 power 50. If you common out 2 power 50, then this is 2 power 50 times of 2 power 50 minus 1. At the end, the required answer is 2 power 50. Okay, once you need to analyze the problem. Okay, there are totally 2 power 100 subsets. Among these 2 power 100 subsets, 2 power 50 subsets, see, think about it. 2 power 50 is not half of that 2 power 100. Is it clear? So some of you may get confused. What they feel is, since there are 2 power 50 subsets with the odd numbers and there are 2 power 50 subsets with the even numbers, since we don't need the 2 power 50, they will say that this 2 power 50 is the answer. But it is not correct, right? Why? 2 power 50 is not half of that 2 power 100. Okay, there are many subsets. For suppose, I will give you some more clarity for you. For suppose if I have a set containing like 1, 3, 5, it is a subset which is there in this 2 power 50. And for suppose if I have a set like 2, 4, 6, here it contains all the even numbers and it is a set in these evens. And there are some other sets where you may take 1, 2, 3, and this is also a subset. This subset is not counted in this 2 power 50 because 2 is there. This subset is not counted in this even subsets also. Okay, so you just don't think about this even set first. You just think about these subsets whose elements are odd and the product of these elements is odd. We don't need that. We need the subsets where the product of the elements is even, and that's why we need to consider all these type of subsets. So to count all these type of subsets, we need to remove these type of subsets. So from the total, just you subtract this 2 power 50, at the end your answer is 2 power 50 times of 2 power 50 minus 1. The problem is very simple, but it needs a little bit of your analyzation skill. Okay, just have a look and then I will discuss the fourth problem. In a college of 300 students, every student reads 5 newspapers and every paper is read by 60 students. Then we need to find the number of newspapers. Okay, see, one more line I need to attach here actually. That in the sense, okay, see, in a college of 300 students, totally 300 students are there and every student reads 5 newspapers. For suppose, since there are different newspapers there and since every student reads 5 newspapers, then the total number of newspapers are simply 300 into 5. Okay, see, actually same newspaper is read by more number of students also, but if you neglect that at first, since there are totally 300 students and every student has 5 newspapers, then you will get totally 300 into 5 newspapers, and it is given that what every newspaper is read by 60 students. Totally there are 1500 students. Okay, if all the newspapers are different, then we need to make 300 into 5 newspapers. But among those newspapers, 60 newspapers are read by, every newspaper is read by 60 students. Since every newspaper is read by 60 students, then all these among these different newspapers, we need to reduce that count by 50, okay, by 60. Totally there are these number of newspapers, and since every newspaper is read by 60 students, then we need just this 300 to 5 by 60 newspapers. That's it. Just you need to think about the question. Okay, see, sets concept is not included here. It's basically an unitary method logic. Okay, since totally there are 300 students, every student reads 5 newspapers, total newspapers are 300 into 5. But it is given that every newspaper is again read by 60 students, so we need to divide this count with 60 and we need to simplify. At the end, if you simplify, 0 will get cancelled, 6 5 is 30 and your answer is 25. So the number of newspapers are 25. There ends the problem. Okay, have a look.